Hello everybody, here we are, and this time we are gonna be talking about some of the pending things. I was supposed to be covering them today, so let's simply get everything done. And once everything is done, then we will be moving to the next one. Of course, I'm gonna be learning something else. Almost when it comes to Kubernetes, so it is more than half. Like as far as the Kubernetes topic is concerned, it is almost done. And as the days come, we will be learning more and more things. And soon, like within a month only, this particular session is gonna be done. After that, what? After that, the main focus is gonna be on the projects. So as for this DevOps section, almost we have already gone through everything. Still, it's not like everything is covered. Things are remaining, and we have to just simply go through them. But as for right now, sort of slowly things are getting done. Okay, so without any further delay, let's simply get started, and it's gonna be quite quick. First of all, what we are gonna be doing, we are gonna be working on the scaling stuff and all. And for that thing, I gotta go to this project learning, and let me delete everything backend. Oops, we had these many things here. Let me just simply delete this, and let me create that scaling again, this scaling folder again over here, and in this particular way, we will be just simply getting the things done. As simple as that. There's nothing here we have, so we will be starting everything from scratch, and we'll try to get the things done. But first of all, if we want to do anything, the most important thing is that we need to have oops folder over that will just simply contain all the DevOps related files and all. And just below this, I will have EKS cluster.ml. I'm just simply gonna be copying and pasting everything over here. Where do I have that? I already have everything in the proper written format, so this time it's all about copying and pasting the stuff. If there are few extra things, I'm gonna be talking about that. First of all, this is the configuration I have. API version, kind cluster config we need. Metadata is what? EKS cluster, this is the name. Region AP South, that's gonna be used. Auto mode config enabled, that's false by default. These are some of the configurations. You can know more about them. I am with the OIDC true. These are the add-ons. And then my nodes is the group of the node. My nodes is the name of the group of the nodes. And instance type T3 small is gonna be used. Desired capacity, this is the desired capacity of the nodes. Minimum can be 1, maximum can be 5, volume size can be 20, capacity type on demand, it can actually be spot as well. You can know more about that. And then going at from here, we have labels here. So label is gonna be worker, and we have SSH, that's gonna be allowed. By the way, what is the use of all these things? You can just know more about them. As for right now, this even if you skip these two things, it's not really gonna make any difference. We have some of the tags: KTH cluster AutoScaler enabled true. That simply means whenever AutoScale group gets created, ASG gets created, at that time these two tags are gonna be added there. And then we have IAM with the add-on policies AutoScaler true. So ultimately, this is also we have here. With the add-on policies AutoScaler true, in the sense AutoScaler will be enabled. So all these things we have for enabling the AutoScaler stuff and all. Okay, so this is the first thing that we have. Of course, quickly we have to just simply create a CD. Oops, we have to create a cluster. For creating the cluster, I'm just simply gonna say one thing, and that is EKS CTL create cluster and file name is gonna be EKS cluster, and just simply run this. Well, there's something wrong with this create cluster. I think what is the problem with this? Loading EKS cluster ML this JSON while decoding JSON unknown field capacity type. Okay, it turns out there is something wrong with this. We will have to figure it out. We are just simply trying to create EKS CTL create cluster, and file name is gonna be EKS cluster ML. What is this? Loading configure EKS cluster ML error unmarshalling JSON while decoding JSON unknown field capacity type. There is something wrong with our configuration right now. I have definitely missed something, but what is that? Let me format it better. Probably format with it with prettier. It doesn't really make any difference. So I don't think there's anything wrong with the EKS cluster. EKS CTL create cluster F EKS cluster.ml. What am I missing here? EKS cluster.ml. This is the error that I'm getting. Error loading config file EKS cluster.ml. Error unmarshalling JSON while decoding JSON. JSON unknown field capacity type. Let me copy this and let me just simply paste it here. Hopefully I will get something regarding this. So error unmarshalling JSON during ML file. Full EC2 access does not exist at a property. This okay, it's fine. EKS CTL utils schema. See EKS config schema for further info. EKS CTL utils schema. Let me check this thing out as well. What am I gonna be getting it from here? EKS CTL create cluster. File name is gonna be EKS CTL this. Why am I getting this error? Okay, let me check one thing here. Do I have any cluster running here already? EKS Elastic Kubernetes service. I don't really have any cluster running here, so in that case, why am I facing this issue? Time to take the help of AI here. What is the reason behind this? This error is actually very common when working with EKS config, and the reason is simple. Capacity type is placed at the wrong place level or not supported in that section. So JSON error EKS ETL does not recognize this field in the place where you use this. So correct capacity type is only valid inside node groups. So metadata node groups old format, and the correct example can be capacity type that I have used. That is the problem. I didn't even have a look at that. This is the capacity type on demand, and common mistake you likely using you probably did something like this. Capacity type is spot wrong top level or wrong selection or inside node groups. So capacity means on demand normal EC2 instances. Spot cheaper can terminate anytime. So if you are using node groups, then capacity type is this. Capacity type is not supported there. In the node groups, capacity type is not, so you must switch to manage the node groups. So ultimately there is a problem with the configuration that I have right now. Great. Let me give it to this one, and almost looks perfect. The placement of capacity is correct. So the error is not because of ML structure. The issue is EKS ETL versioning outdated. So older versions of EKS ETL do not support capacity, so they throw this error. Confirm EKS ETL version. If it shows something like old less than this, that's the problem. Let me see. EKS CTL version, there is 0.2. Well, this is not fixed updated. By the way, the version is not quite old as well. In that case, what is the issue? I thought it to be quite straightforward, but as long as I'm facing this is already the recent version. Auto mode config enabled for this field is not supported in standard EKS CTL, only supported in specific experimental. That's right. And fix remove this. Even if I remove this, nothing's gonna be happening on demand. Now run it again. Let's see whether it actually fixes this or not. Enabling, removing this, I don't really think it will make any difference over here. Yeah, I still get that. While decoding JSON, still getting that. So alright, since your version is latest, looks correct, this means something is more unstable or wrong. Most likely cause you are using field that EKS doesn't expect, even though you wrote manage node groups. So sometimes in intention is node groups add capacity time is not supported, then step by step EKS utils validator cluster EKS cluster ML. This will show the real parsing issue. Utils validate cluster, it will be validated. Let me see. Error details EKS util unknown resource type validate. Check indentation carefully. Quick test temporary remove capacity type on demand, then run. I think that's the main problem. If I remove this capacity section from here, it will definitely work. So let me do one thing. Let me keep it like this, and this should definitely work. As expected, cannot find EC2 pair SSH ID RSA pub. EKS CTL SDC get caller identity. Did you mean set? I think this is the command. EKS CTL. I do have it here. What is the command then? Alrighty, time for a quick go through. Somewhere I had this EKS CTL STC. So EKS, okay, let's go through this one. So that is actually AWS STC, fine, not EKS. AWS STC get caller identity. I do have it here, and once I have it, in that case EKS create this. Cannot find EC2 pair key SSH ID RSA pub. It is unable to find this. Why it is trying to find the EC2 pair key? Because if it needs to create the EC2 machine, this needs to be there, RSA pub key. Fine, let's check that thing out as well. And over here I have these ones. Let me try to run that again. EKS CTL create cluster, error reading config file, open cluster ML, no such file or directory exists. That's right. Alrighty, finally it came back on track, and as it has come back on track, so this is the error. Node group my nodes will use Amazon Linux. This is the issue that I'm getting here. Let me try check this thing out. Good news, your capacity issue is solved now. There is a new completely different, much simpler. Cannot find this, meaning EKS CTL is trying to enable SSH allow true, but it cannot find your SSH public key. Why this happens? In your config you have SSH allow true. This tells EKS attach my SSH key to EC2 instances. But you didn't provide a key, so it tries to default, but it doesn't. Fix options. Recommended for beginners, more secure, works immediately. Generate SSH key, so I can just simply generate an SSH key, and once I have that, it is gonna be working. SSH allow true. Public key is gonna be this, so I can even specify the path name. So in this way, what will happen? I can SSH into the machine that I get, EKS machine. Interesting thing, yeah. That's actually a good thing. So let me do one thing. Control W. I'm going to be changing this a little bit. First of all, when it comes to this SSH, I'm going to be having this path as well. And your SSH key, that's gonna be what is gonna be the key over here? I already have the key, right? What is the key name? The one that's gonna be used here, cd this dot ssh ls, and that is this public key that's gonna be used. So AWS EC2 ID, the same key I want to be used here. So this thing is done, and right now I should not be getting that error. And let me turn this on as well, probably capacity type. Hopefully we'll not be getting that error, but let's see. Error reading the well of course, oops. Let's simply run the same command, that capacity type. So it is just simply saying JSON unknown field capacity type. So it is just simply not recognizing this particular field. So let me do it like this, and now it's gonna be working. So for some reason it is unable to find this field, or it is just unable to recognize that. But never mind, this much configuration is enough for right now. I don't know, for some reason it is just unable to recognize that. So let me duplicate it, and coming back to this Kubernetes section, web dev, over here, this whole thing needs to be replaced right now. Few things are clear and few things are still okay. Let me paste it here. So one thing is clear, that it is unable to recognize this capacity type on demand for some reason, and that is why it was just simply throwing me the error. Apart from this particular thing, I added this public key path over here, and the public key path for my public key that just simply connects. So ultimately with this much configuration it is started working. For some reason it was not working with this. I'll figure it out later. As for right now, it is definitely getting created. So soon the EKS ETL machine or what? EKS cluster will be created, and once the EKS cluster is created, we are gonna be starting to work on that. Apart from this particular thing, we will definitely have to wait for it, and then we have to just simply create the machines. And also once the cluster is created, we will have to create the policy, RBAC, AutoScaler. I will be talking about exactly what they do and all, but overall these are the steps that we have to go through. Again, I went through these steps in the morning. We will be going through them here as well, and hopefully everything is gonna be working the right way. And apart from this particular thing, there is something called Helm that we have to talk about. So let me create a kind, when it comes to the Helm, it can be used locally as well. Like we can just simply create local cluster for that. So kind create, well, ls, we don't really have any configuration for that. So let me have a vi, a local cluster here. This is gonna be the configuration for local cluster. And as for the configuration, I already have it here. So EKS cluster, local cluster, what is the configuration for that? This is the configuration for the local cluster. I don't really remember anything. What is the use of even remembering the stuff when copy paste will work? Okay, if you understand the code, what I think, like it, once you are able to understand, that's more than enough. By the way, let me format it. So this is the configuration for the cluster, simply saying that one control plane, 2 workers, and nothing else. Let me simply apply this as well. So kind of create cluster. What is the configuration? Config is the local cluster, and the name of the file is gonna be local over here. That's gonna be more than enough. Local cluster is being created over here. We will quickly start working on this Helm thing, because AWS is gonna be taking some time to spin up the project, spin up this EKS cluster. So until then we can just simply go through this thing, right? Helm thing. So what is the package management? We already know what is the package management. We have used npm in the past, and I mean that simply lets us manage the packages and all. So we don't really need to worry about exactly what is package management. The way npm is for node, and similarly there is something called there must be another package for Rust as well. For different languages there are different packages. For Python there is something called pip. For Node.js there is something called npm, and similarly there are different types of packages. And similarly here in Kubernetes we have something called Helm. This is kind of a package manager. So using Helm you can just simply install some packages directly. So what happens that there are two ways. Either you create your whole configuration on your own, like the way we are doing over here, not this one, but deployment and all. You write the whole configuration, or you just simply use the pre-written configuration that has been written by others, and using the Helm you can just simply get it done. By the way, I will be talking about exactly how it works. Kind get clusters. Here we have the cluster. Well, we have two things over here. We have local cluster and we have local. So kind delete local is something that I have just created right now. Local cluster was here earlier, so kind delete cluster, and the name is gonna be local cluster. Let me just simply delete this. So it should be deleted. Kind get clusters. So I have this local cluster. K get nodes. I have these nodes right now. What is the next thing that we have to do? Why package management in K8 in Kubernetes? So the thing is simple. To start a progress in your K8, you will have to create a deployment. Then you will have to create secret, service, PVC, and namespace and all. So ultimately, if you actually wanna deploy a project, so you will have to create tons of things. Like you will have to create the deployment, secret, service, PVC, persistent volume claim, and namespaces. And every time you will have to configure them. Every time you will have to rewrite the configuration. So ultimately, code is going to be repeated. And for that thing, what you can do, you can just simply create a Helm template, and you will be just simply giving it the values, and it will be just simply creating everything for you. We will be talking about that exactly how it works. That file would look like something this. We have already talked about it. We are creating a namespace, then we are creating some secret. Okay, after that we are creating the deployment. After that we are creating a service. After that we are creating a persistent volume claim, and this is how it just simply goes on. So wouldn't it be nice if we can get the Postgres manifest from somewhere? So ultimately, either you create the manifest on your own, or you just simply get it from somewhere. How it works and all, we will be talking about it. Benefits of package management. I mean, of course, let's simply go through it really quick. Templating and reusability. So what will happen? That the first thing is that you just write the whole configuration again and again, and the second thing is that you create a kind of a template. Helm helps you do that only. So untitled file, let me go to this one. So what is the use of Helm? Let me just discuss that briefly over here. So coming back to this one. So the first thing is that if you want to just deploy any project, so how many things you will have to create? Probably if you want to deploy that, so inside a Kubernetes cluster, you may have to create first of all deployment, just like this. So suppose this is kind of one part. Suppose you are deploying a backend, so create a deployment, create a probably replica sets. I mean, deployment will be just simply creating everything. So you will have to create the deployment, you will have to create a services, you will have to create a namespaces, you will have to create a PVC. If you are using database, you will have to create what else? Ultimately, you will have to create HPA. So ultimately, there can be many things that you will have to create, and this is for one app only. So if you are using one, then create these many things. Then if you are using another, if you have another app, then you will have to go through the same process again. If you are using another, so suppose this is for the back end, this is for the front end, this is for the database and all. So in this way, you will have to just simply repeat the logic again and again. What is the solution for this? Just create one template file. So you just created a template file for the deployment. So deployment template file. So this is gonna be the template file that you created. Similarly, you created a template for services. So ultimately, what you are creating templates over here. So you create a template for deployment, you create a template for services, you create a template for namespaces, you create a template for PVC, you create a template for HPA. So ultimately, you create a template for all these things. Then what will happen? Then once the template is created, you have to just simply give the values. So probably you are gonna be giving it, just a minute, you are gonna be having the values for backend. So you can just name it backend slash values, and inside this you will have backend values, then front end hyphen values, and then db hyphen values, then you will just simply have the value. So what will happen, you will just store the values in files, and from here you will just simply be passing the value to this template. So in this way, what is happening, you are just simply creating the template once, you are just simply passing the values. What are those values going to be? That can be your name, that can be your namespace name, that can be your port number, that can be your image, that can be your tag, that can be anything that may be used inside this template. So this is how it just simply works. How it works in practical, we will be just simply going through it. Ultimately, you are going to be just simply creating a template, and you are just simply going to be passing the values. That's it. So in this way, you will not have to rewrite the code for the template again and again. And not only that, you can create a template for you. You can even get the templates for, created by others. And this way, your overall logic is going to be like not repeated again and again. By the way, benefits of package management. We are managing this stuff. Again, you will be creating the packages and all. So whenever you are just simply templating things, so you can make sure that, okay, this is the version of this template. Not only that, this is the version of this deployment being used over here. This is the version of a particular app inside the deployment. So inside deployment, you will have template, right? You will be running some app. Probably you are running Postgres, so probably you are running some backend. So you can specify the proper version of that. If I'm running Postgres, so this version of the Postgres should be used over here. So you can just even define that. Coming back to this one, templating and reusability. Helm uses templated YAML files, allowing you to define reusable parameterized Kubernetes manifest. Instead of writing complex YAML files over and over, you create a chart once and reuse it with different values. Create chart once, reuse it with different values. This is just simply goes on. Versioning and upgrades. Helm allows you version your application deployments, making it easier to roll forward or backward in case of issues. You can upgrade or roll back releases with a single command. You can just simply roll back or roll forward. Both of these are possible. It will be just simply managing the version of the package as well as the Helm. Dependency management. Helm supports dependency between charts. If your application depends on Redis or PostgreSQL, you can include them as subcharts instead of manually managing each. Okay, this is something. You can include them as subcharts. Okay, not aware of it quite much. In future, I will be learning more about it. But overall, how it's created, we will be going through that. Release management. Each deployment with Helm is a release. Helm tracks releases, so you can inspect or revert to previous state, which helps in troubleshooting and auditing changes. Next one, simplified sharing. Helm charts make it easy to share applications. Public repository like artifact hub or private chart repos let teams distribute complex applications without needing others to understand every ML details and all. Even if you don't understand how the ML file is written, you can just simply import that, give it the values, and the job will be done. Having said that, you should know that. Consistency across environments. Using Helm, you can deploy the same application in dev, staging, and production with different configurations, ensuring consistency with flexibility. The thing is that once you create the template, you can just simply deploy it anywhere by just simply changing the configurations and all. Okay. So this much we have gone through. This was just the intro part, and I hope by now even what is the next thing that we have to talk about. Let's continue with the experiment part right now. We are gonna be experimenting it. Create a new KTH cluster, install Helm CLI, install. By the way, for that thing you need to install Helm CLI. Google how you can install Helm CLI, and you can continue with this. And let's come back here and not this particular section. By the way, we are talking about two things over here. Let me duplicate it again. Coming back to this one, I need to go to Helm part over here. So this is the Helm part, and you can just simply run. So what you if you have Helm installed, so you have to just simply run this command: Helm installed Postgres. This is just the name of the deployment, not even the deployment. Helm process that you are starting. That process will mainly be responsible for creating the deployments and all. So you can just simply get the ML code written for Postgres SQL by default. So you don't have to just simply create a ML configuration for Postgres SQL. Rather, by running this command, you can just simply get it. So if I just simply run this command really quickly, it hasn't been get nodes. I hope local one is running right now. Nope, not local one is not running. Rather, it has been connected. to the EKS cluster right now. Great job, by the way, as EKS cluster is running, so we are gonna be going with that. By the way, we are still gonna be using Helm over here. Let me exit. It is just simply saying that it is just doing something or the other still. Let me switch context here quickly, because it is still gonna be taking some time. So k configure and get contexts, k configure use context. I'm gonna be using this particular local cluster over here, that would be better. So let's simply, well, there should be gap, k get nodes. Right now, wait, I don't have Docker running or what? I have Docker running. K get nodes, k get k configure get contexts. So I have local cluster running right now. That's a good thing. I have three things over here. I have local cluster and I have this. Oh, got it. I have to use local here and local cluster I need to remove. So k configure use context kind local. First of all, this one needs to be used, and k configure delete context, and that is local cluster. Let me delete that as well. K configure get contexts. So I have two ones right now. Kind local is being used. Great. Even this is ready right now. So let me just simply use this too. K get nodes. By the way, local cluster is being used. It's gonna be a bit faster, so I'm gonna be using this with Helm. You can use even I can even switch the context. So k get what? How can I switch the k configure get contexts. These are the two contexts that I have. I have this EKS cluster and I have this local cluster running. So if I want to switch to EKS cluster, so I can just simply say k configure, k stands for kubectl over here, k configure and use context. And what is the context? This one we want to use. It has been switched. K get nodes, and right now I'm gonna be getting the nodes of these nodes I'm getting, they are from the AWS side. Alright, what is the next thing? The next thing is that we have to just simply run this command. What will this command do? Let me show you. As soon as I started running this I'm really bad at copying the stuff. Copy it. Once I have this particular command, let me paste it over here. Let me run this. What will this do? It will get the configuration, ML configuration of PostgreSQL, and it will just simply start running that. That is the only thing that it will do. So let me just wait for a while, and hopefully it's gonna be done quite quick. It has done this thing. There's a lot that you can just simply read about it. But if you run k get Helm list, so you are gonna be getting this name, that Postgres name is PostgreSQL default 1. It has been deployed, and ultimately one Helm list you have. This Helm list has the configuration of like it has the chart PostgreSQL chart of PostgreSQL. Chart in the sense it has the whole configuration for PostgreSQL, and it even has the started PostgreSQL. So if we say k get pods, so you are just simply getting that SQL that is pending. That simply means that is about to start. You did nothing. You just simply ran this command, got the configuration of PostgreSQL. It automatically started running. Even you must have the k get deployments as well. Deployments. So even k get deployments. We don't have any deployment. Probably just simply started at this only pod only. Yeah, it just simply started the pod. That's fine. So k get pods, it simply started this particular pod. It is just simply not running yet, so soon it will start running. Apart from this particular thing, k get SVCH, did it create any services? Yeah, I did create some services over here. So these were the services that were automatically got created. You did not have to do anything. So this is how it is mainly used, and you can just simply pull the images as well to see files being applied locally. Run this Helm pull, and this will be just simply pulling the image. That's fine, and unter. So ultimately what all it is used. So let me just simply run this locally as well. Hopefully I should be able to copy the stuff. Let me copy this. It has been copied. If I run this particular command, then what will happen? it will be giving me all the files that are being used locally, if I'm not wrong. So let's check this thing out. By the way, it has just simply started, it hasn't really done anything. So okay, Helm list. I still have one, but if I want to see that, so okay, Docker images. Clear ls Helm list. I don't have that as well, but okay, ultimately if I write Helm ls, so I'm getting this particular Helm is being used. Ultimately we got the chart of Postgres SQL, and that particular chart has the configuration for the Postgres, and because of that thing it has started a pod called kget pods. If I run this particular thing, so I got a pod that is in the pending state, but that is definitely if I just pass the proper it should be working anyway. Let me just simply go inside that. So k logs probably of this one. Why is this not running? We are not getting the pods. Let me try to describe that. Describe pod just like this. And 0 by 2 nodes are unavailable. Pod has unbound immediate persistent volumes claims not found. We need claims for it, and we don't have any claims as such. That is the problem. Interesting. As far as the claims are concerned, that simply means we will have to create proper claims that will make sure that it is actually able to use the persistent volumes, but we don't have that yet, and that is why it is just simply facing the issue. So if I actually want to make it run, first of all, locally it is definitely gonna be running, because locally it will create the volume locally. So like when I'm using this local cluster, so it can use the volume locally, and when it comes to this one, so I will have to create persistent volumes. Yeah, and I will have to configure this stuff locally in the sense k get k config get contexts, and k, by the way, let me do one thing, Helm list, and Helm, let me uninstall this as well. Uninstall, I'm gonna be installing Postgres, this one that I want to install, the name was Postgres. So this has been installed. So Helm ls, I don't have any, and even if I try to get get pods, so I'm not gonna be getting any pods. Having said that, now I'm gonna be switching to the local cluster over here, and for switching to the local one, I need to just simply copy this. So k config use context, I'm gonna be using this context over here. It has k get pods. Right now I have switched it to the local one. I don't have any pods anyway. K get nodes, I will be getting the local nodes, and I'm gonna be running the same command in the sense, the same command, this one is going to be used here. Locally it should usually work, because it will just simply get the local standard volume, a persistent volume, so that should not be problematic thing. But let's see, k get deployments, I should not have any deployments, but let's see, k get replica sets, no, k get pods, I have one pod that hasn't started yet. So k describe pod, and I'm gonna be describing this pod over here. Let's simply run this, and it is saying that successfully, first of all, pulled the assign default Postgres SQL to local worker 2. So it has assigned it to the local worker 2, and then spec containers Postgres pulling the image registry from this. So it is even pulling the image and all. So yeah, it is sort of, it should be in the watch mode or something. This does not work. Okay, never mind. Let's simply run this, and what all it has done, it has pulled the image. Once the image was pulled, it has just simply started running that as well. So locally it works. On AWS EKS it did not work, because it needed the storage, and no PVC was defined over there or configured over there, and because of that thing I was facing the issue. So this is how it works, and k get pods, right now it is of course in the running condition, one by one, both of them are running. And if I want to stop, by the way, if I want to stop the pod, let's see what's gonna happen. So k delete pod, and I want to run this particular, delete this pod, k get pods, it automatically starts a new one. So ultimately it just handles that for you, so you don't really need to worry about it. You just need to wait for a while, and it will be started. Okay, now it has started, as simple as that. Apart from this particular thing, if you actually want to stop it, so Helm stop, Helm uninstall, and what is that? It is Postgres. How do I know it is Postgres? Helm ls, the name is the Postgres, so I can just simply install that, and it will be removing all the pods and all. So Postgres uh, Helm uninstall and Postgres. This is how it will be installed. So, okay, get parts. I'm not gonna be getting any. So this is how it just simply works. First of all, here we use the image Helm chart created by others. Similarly, you can create a chart, kind of a template, and you can use it on your own. By the way, this is something I haven't gone into quite deeper. I haven't gone deeper into it, but I have just overall idea exactly how the things work and all, and that's what I'm discussing here with you guys. It is not something I I'm even planning to go deeper into, because right now I'm just simply gonna going with the normal configuration the way I have been doing this stuff. But definitely in the future I will be digging deeper into it. I will be exploring it even more. But for now, whatever the idea, not even the basic idea, almost I know as much I should know right now at this particular level. Okay, let's simply go through that. So by the way, coming back to this one, Helm uninstall, we have done this particular section. If you actually want to install that, so let's talk about that particular stuff here. And then of course we have to move to other things. So first of all, we are covering this Helm thing, and then we will be starting something else. Okay, fine. Chart registries. There are two things, artifacts hub and Bitnami. They are mainly used for, if I'm not wrong, pushing the charts. So the way we push the images to Docker hub or something, Docker hub of course. The same way, I mean, we even when we create packages, so we simply save them in npm package manager. So the same way they are being saved there. So let me just simply copy this and see what this is all about. So charts.bitnami, the Bitnami library, I hope this is the correct pronunciation, library for Kubernetes, popular application powered by Bitnami, ready to launch on Kubernetes. Helm repo add Bitnami https this, Helm search repo Bitnami, Helm install my release, and this. So this is mainly used for getting the packages. So Helm repo add Bitnami, and then https and this, Helm search repo Bitnami, and for more information you can know more about it. But this is something we can definitely explore together in future. As for right now, whatever we have gone through, that's more than enough. Okay, so this particular thing is done. There is another thing, that is artifact hub. So let's simply go through that as well. And I think from here, these are the packages, Helm packages and all. From here you can just simply install the Helm charts, and once you have, like, from here you can just simply get the links, find and install publish cloud native packages. So from here you can just simply install them, and once they are installed you can just simply use them, as simple as that. By the way, there can be charts or templates for many of the services over here. You can just simply explore even more. For now I'm just simply gonna be saving the links. Definitely will be exploring in the future. Coming back to this one, we have gone through this much. Delete this. And what is the next thing that we have to go with? Charts register. These are the chart registries. Charts registries in the sense, once we create the chart, you can just simply save them there, and then other people can just simply use them. Let's talk about the templates. What are Go templates similar to Node.js? We have already talked about templates, exactly what they are and all, so we are not going to be talking about it. But let me have a quick look. So Go templates are, you have templates in Go, you have templates in Node.js as well. There is something called EJS, the way EJS templates work. The same way we have templates here as well in Helm. What are Go templates similar to EJS in Node.js? Go templates are simple and powerful templating engine in Go programming language. They are designed for creating text-based output like ML, HTML, etc. by embedding Go logic inside placeholders. And we are discussing about Go over here because at the end Helm uses the same way. Go templates are used to generate Kubernetes ML files dynamically based on input of values and template logic. So ultimately, the way we are gonna be defining the template, that is just the way Go templates work and all. So ultimately, we are gonna be using Go templates over here. I don't know whether you have gone through EJS or not, but in Node.js there is something called EJS. Here, when you are working with Helm, and if you are actually gonna be creating a template, so at the time, what is that? Go templates are being used. I will be talking about exactly how it works and all. So ultimately, what will happen? Go code for templated file. So you have package main, import these things, user struct to hold individual data and all. Okay, that's fine. Let me just simply have a quick click on this. Honestly, I don't know Golang, but I know how this template stuff works. and this is how you can just simply go through it and go for serving this. Fine. Let's come back to the main point. In Helm, templates are defined using the curly brackets, sort of start of the templating, like double curly brackets and all, and accessing variables. You can just access the variables using dot and then some variable name. Control flow, you can even have the control flow inside them. So this is how you will just simply be going ahead. Again, as far as Go templates are concerned, we are not gonna be going quite deeper into it. I don't even know Golang language, Golang or Go, whatever that is. But I know how the template system works, so I'm gonna be talking about that. Why templates? They can't be generic chart. But there can't be generic chart package that you can create. There can be or can't be. There can't be generic chart package that you can create that caters to everyone need. Hence, when a chart is created, most values are injected via templates. So ultimately, what is gonna be happening? You are gonna be creating some kind of chart, and you will be just simply injecting the values. So ultimately, you will create a template, and you will be injecting the values on top of that, and then that template will be using the values and will be doing whatever you have configured that to do. And this is how it's gonna be going on. So we have some values, we have a chart, kind of, we have a template that is called kind of a chart. The values and the template, including chart and all Postgres manifests, and this is how it's gonna be going on. Okay, we have already gone through this really quickly. Let's create our own chart right now. So we are gonna be creating a chart. That's gonna be interesting stuff here. So this were the quite easy peasy stuff. Let me even get rid of this. We haven't really used this right now. It's time to create our own chart. /code create chart. So we are gonna be creating Helm chart over here. For creating the Helm chart, we can just simply run a simple command, and that will be used for creating that. And I don't think that command has been mentioned over here. Yeah, that hasn't been mentioned. And what was the command anyway? I forgotten. Command for creating Helm chart. Helm create name. Helm create and the chart name. Okay, so what kind of chart we want to create? So let me go with this. So the simple command is this: if you want to create a Helm chart, and you will be getting some configuration by default over there anyway, so you won't have to configure that much. So coming back to this, actually maybe this, the first command that you need to run, Helm create, and whatever you want to create, the chart name ultimately. So chart name is gonna be here. Suppose we want to create the chart for probably Postgres, so that's gonna be Helm create Postgres chart. So ls Helm create Postgres chart, just like this. Just a minute, let me see if I'm missing something. Creating your own Postgres. Helm create, this is gonna be the chart name, and that in the current directory. We are just simply going through this, creating your own chart. So this is how we will have chart.ml. this is the metadata manifest. Okay, that's fine. We will have the ml, we have already gone through this. We will have a folder and done. Coming back to this one, for creating that, we are gonna be creating in the current directory, right? So Helm create Postgres chart, we wanna create. It has been created, ls. So this is the Postgres chart folder that we have, that automatically got created. cd Postgres chart ls. We have these many things inside this. Let's talk about them one by one, exactly what they are. I just ran one single command, the chart got created, and then we will be making the changes as per our need. So Postgres chart, this got created right here, and inside, oops, well, am I inside the right folder? How did this get created? Probably I ran this command by default, by mistake, not by default. Let me delete this. So probably I ran that command by mistake. Coming back to this one, so we created this, so Helm create and this, so ultimately Postgres chart got created. Inside this I have the values. What are these values? We are going to be talking about this. There are some default values, you can just simply go through and all. They are nothing but the values, like service.type you will be getting the service.port you will be getting the port number, and then some other things. Even you have the replica count one, you can just simply get the value from here, and you will be using the value inside the chart and all. So let me just delete everything. I will be rewriting it from my own side. Chart.ml, this is the kind of configuration that you have. Again, you can just simply go through it and just know more about it. I'm gonna be just simply deleting these comments. This is nothing but the metadata that you need to have for your Helm chart. So ultimately what all you have over here, API version 2, Postgres chart, this is the name. A Helm chart for Kubernetes, you are just simply trying to create a chart. Type is application, version is gonna be this, and app version is gonna be this. App version in the sense which version of the Postgres, if you, this is a Postgres chart, so which version of Postgres you are trying to use over here. So this is the thing that we have gone through, and we will be even going one step further once at least basic things are done. But before that, let's simply stick to this one. And once this thing is done, then if I go to template, I have these many things over here. I'm gonna be deleting this template because we don't have what we need here. So I'm gonna be just simply creating templates again from my own side, templates again, and here I will have my own things, whatever I need. I ultimately want to create a template, right? So we have gone through this much. Let me create a chart.template over here. I want to have what chart.template is already here, so we don't really need to create that. Values we already have, so we don't really need to create them. Let me have some values over here, and when it comes to values, suppose if I want to run Postgres, so I need to have suppose name. What is gonna be the name over here? Name is gonna be suppose Postgres chart. Suppose this is the name. Okay, and what is the next thing? Name for what? Name for the name for anything. Wherever you need this name, this is going to be used. Then we need to have Postgres user as well. So Postgres user, that's gonna be equals to suppose Postgres user is gonna be equals to probably Dipendra. I mean, I hope this is the right way. Do we have to add the Postgres user? What should be the value of the Postgres user in Postgres? What should be the value of Postgres user in Postgres DB database? In Postgres, the value of the user depends on the context setup, standard Docker container. So the default name is the customary name for initial predefined super user is Postgres. So the user Postgres user by default defaults to Postgres. That's great. By default it is nothing but Postgres over here. So let me have Postgres as well. So default name is gonna be this, and I have Postgres user. Similarly, I can have password as well. So Postgres password. These are the values that I will need for what? These are the values that I will need for Postgres application. Sorry, just simply suffering a bit. That's gonna be password 1234. Can be anything, or Postgres 1234. Postgres 1234. This is just nothing but the password. Similarly, you can have the namespace, or like what's gonna be the time, because of course we are gonna be using namespace in the what, inside the deployment and all. So namespace name is also gonna be here. Suppose that's gonna be Postgres team for now. This is how we are gonna be going ahead. And lastly, we will have the image, what image you are gonna be using, and we will have the repository name over here, repository name, and the repository name, suppose we want to go with the Postgres, and there's gonna be tag for that as well. And suppose we want to use 15 tag or 16 tag, doesn't really matter, whichever version you want to use, you can just simply use that. So these are nothing but the values. That's it. This is what you have to do. So what we are doing, we are just simply having all the values. Once we have all the values, after that I'm gonna be creating a template for myself. So I already have this configuration, chart configuration. I already have the values that are gonna be used inside the Postgres, and you already know you need the name, user, password and all. And let me create the template. And for creating the template, I'm gonna be using the predefined template, but I will definitely be explaining that. So I'm gonna be having deployment.ml, and deployment.ml will have this configuration. Let me just simply copy and paste the things over here. I will be talking about exactly what they do and all, not worry about that. And apart from this template, I'm gonna be having service template as well. So service.ml. So this thing I'm gonna be having here. As for service.ml, I already have this already created. Let me paste it over here. We'll be talking about each and everything. No need to worry about that. And lastly, I'm gonna be having the namespace, and the namespace should be running at the top. Should be at the top so that it runs first. So 0.namespace.ml. Why am I naming 0? So that it remains at the top. If I remove this 0 from here, it will be after deployment. It will be in the middle, and I want it to be at the top so that it is namespace gets created first. Let me just simply add the values here, and that is it. Once we have done this much, then we can just simply Helm install the chart, and it will be created. By the way, coming back to this one, these are the templates that we have. First of all, template for what? First of all, template for namespace. What am I doing? I want a namespace, simple. Metadata name. What should be the name? Name should be .values.namespace. After .values, whatever you keep, that this namespace value actually comes from this values. Simple. You already have this namespace name over here. So this namespace will be used. So Postgres team is the namespace. So the same will be used over here. So ultimately, if you want to access the values here from the values.ml, simple thing you have to do, you have to write .values.namespace, and the job is done. Simple is, it's really simple. So it's like you have the values over here, you have created the template over here. Now you just need to have all the values, run it, and the template will be used, and whatever you want to do, the template will be configured, and whatever job is template is configured to do, that job will be done. Similarly, we have deployment over here. I want to create a deployment metadata. What is gonna be the name over here? I haven't defined any name directly. I'm just simply saying .values.name. Simply says that from the values, just get the name. From the values, what is the name? Postgres chart or Postgres DB. Let's name it like this. This is the name. As simple as that. This name is going to be used over there. Pretty simple, right? Coming back to this one, deployment, we have this namespace. What is the namespace? Values.namespace. That is what Postgres team, that's gonna be used over here. Similarly, I want one replica. I can even make it customized. Ultimately, everything can be configured, but when it comes to database, we just want one database running, right? So that is why we just have one replica over here. Selector match label. What should be the label? App values.name. Values.name in the sense this Postgres DB is gonna be the label as well. Great job. We have already gone through this. What is the next thing that we can do? Coming back to this one, deployment. Similarly, template. This is the same name is gonna be used over here. It's literally the easiest thing ever. Containers. What we want to use? We want to use Postgres. Okay. What is gonna be the image of the container? By the way, this even we can configure this. What is gonna be the name? The name is gonna be this dot values dot name. We can use it, of course, over here. And then what is gonna be the image? The question is, why am I using this over here, this quotation marks? The thing is that this tag that I have, this is gonna be number, right? And most of the numbers, they are rounded, and I don't want that number to be rounded. That is why I have used this string over here. Okay, and what I'm gonna be needing, values.image.repository. First of all, the repository name, and then values.image.tag name, and that's it. Once I have this, I have the everything. Alrighty, and then name, environment variables, few environment variables that I'm gonna be needing. I need my Postgres user. What is gonna be the Postgres user for this particular image? So Postgres user is gonna be equals to .values.postgres user. This is the Postgres user. As simple as that. This is gonna be used. So ultimately, if you want to get these values, you have to just simply say .values.anything, name Postgres user, this, and if you want to get a repository, so image.repository, whatever, repository. This is how it's gonna be used. I hope it does make sense. Alrighty, so this particular thing is done. Similarly, I need the password, values.postgres password. I hope that's the right name. Postgres password, Postgres user, that's the one that I have over here. And lastly, I have Postgres DB, Postgres database name. Do I have it here? Postgres DB values. I don't have Postgres DB over here. Let me have it, and that's gonna be my DB probably, or Postgres DB. What? Google DB. Ecom DB. Let's make it like this. This is gonna be the name over here. So the database name can actually be anything. I just named it like this. And once you have this name, Postgres password, database, and a database name can actually be anything. So we have done this thing. Even it can be Postgres DB, but I already have the name, so skip that. And what is the next thing? Once you have this Postgres container, even you can configure this container as well, like okay, like you will be specifying the port number, but most of the time port number is gonna be 5432, so we are not simply configuring it. So that's it, the job is done. Similarly, you have the service over here. When it comes to the service, so what you are doing, API version, okay, I want service. Metadata, what should be the name? By the way, let's get rid of this, let me have it simple. The name of the service is going to be dot values dot name. By the way, this should be sort of service name, so I can say, I can come here, I have the normal name, and I'm gonna say that I'm gonna be having service name as well, and service name is gonna be Postgres service, just like this, as simple as that. So this is gonna be the service name that I have. In order to get the value over here, I'm just simply gonna say that instead of having the name, service name, I'm gonna be having over here name values, values dot namespace, the same namespace I want to use. And similarly over here, what is gonna be the selector for it? Selector should be the same, because ultimately service needs to select the same ports, right? So it's gonna be using dot values dot name, and because I have used this inside deployment as well, the same value was used, so this needs to be the same. So this particular thing is done too. What is the next thing? Service port number, ultimately my service, the service that I actually have, this is gonna be running on 5432, and target port is gonna be running on 5432. This service is having said that not complete. Why am I creating this service? This service type is what? I don't have any service type over here. Service is definitely gonna be created, and it is just simply saying that service is gonna be running on this, and probably service needs to run on port 80 by default, any service for that sake. Service can actually run on any port if that is a node port. Otherwise, if that is a cluster IP, then of course it's gonna be running on port 80. Suppose let's make it a cluster service so that it is accessible inside the container only, and type is gonna be cluster IP. So hopefully this is the right. How is the cluster IP made? Helm, EKS, EKS cluster service edge. When it comes to service edge cluster IP, what is the type here? The type is the cluster IP. It is in the capital form. So cluster IP. One more thing that I forgot to mention over here, that's gonna be protocol, and protocol, that's gonna be TCP. Protocol TCP, port 3000, and ultimately these are things that are mentioned over here. The configuration, you can configure it the way you want. Usually we will have these many things inside a service. Once we have everything, what we are going to be doing, once we have everything, ls, I'm going to be just simply running this, and for running this, simply helm install and everything from the what is the name. So helm install, the name of this is a Postgres chart that we named, so Postgres chart, and that is from the current directory. So from here I have to just simply install this. Values are already here, so all those values are gonna be used. Let's simply run this. Well, there is a problem. Installation failed to create a typed patch object Postgres service version kind type field not declared in schema. Type field is not declared in the schema. Okay, and that should be like this, and now I should be running it. Well, the next problem, label error, message release name check failed, error, can't reuse the same name that is still in use. Installation failed, release check failed, can't use the same name that is still. The same name is used, Helm list. So ultimately this one is already running, so it was just simply saying that it cannot use that. So let me delete this. Helm uninstall Postgres chart 1.0 uninstalled Helm ls. Well, that's still running. Okay, uninstall Helm uninstall. I want to install this. That's installed, and once that is installed, so helm ls, I should not be getting that. And if I run the same command one more time to just simply install, so it's gonna be installed. So ultimately it is deployed successfully. So right now if you try to get a k get pods, you are getting, well, you are not getting the pods because it belongs to namespace, what namespace, Postgres team. This was the namespace. So you are getting your Postgres running. Not only that, kget deploy mens, and namespace is gonna be Postgres team. You will be getting the deployment as well. So one by one deployment is running. Even you created the service, okay, get svc, and the namespace is gonna be Postgres team. So you are getting the service as well, the cluster that you created listening on port 80 and all. So yeah, this is how the this simply works. And right now, if you want to create more, like, so in that case, you can just simply specify the value, exactly which value you can use. You have this value, you can have many more values, and this way things are gonna be done. I hope this does make sense. And Helm template progress, explore the pods, svc Postgres, Helm template, Postgres. Should you use my Postgres.name or my Postgres file name? Okay, this is it. And how can you start to different apps? Can you make the pods templated as well? Alrighty, these many things that we have gone through right now. There's one more thing that is remaining, going a little bit deeper into it, exploring it a bit more. That is something I will be getting done later, because right now there is another thing that we have to focus on. Whatever we had to go through, we have gone through right now, at least for now. And I'm gonna be just simply keeping everything in the notes. So this is the command that we ran for the first time. That should be actually Postgres chart. This is the command that we ran. This is just nothing but the name. And what is the next thing? Once we ran this, we just simply remove the template. That's fine. And we had some files over here. First of all, this is the file that we have. And almost we have everything here. A few files here. That's gonna be, first one is gonna be what, 0 namespace.ml. This is gonna be what, inside templates. All these are gonna be inside templates. So I will have some templates here. So let me have it really quick. ts2 templates slash, I will have few things here inside this self-created template, because by default the templates that I get, there's a lot of configuration there, like they are not the ones that I need. So namespace.ml, this is the first template that I created, and inside this, as for the code, let me just simply copy and paste the code, so that in future I can just simply get the reference from here, and I know that this is something that's gonna be definitely working for sure. And even we have to dig deeper into it. And second one is gonna be deployment template, deployment.ml. Alright, here we are. And deployment.ml, let me just simply cut, copy, paste, nothing else. This is how it's gonna be going on. Lastly, what do we have here? Lastly, we have service.ml. Again, you can create any kind of templates. Whatever we created right here, we are just simply gonna be having it just for the example purpose. Done. So ultimately this thing is also done. The last thing is that we have a chart.ml. This was automatically created, so we don't really need to worry about it. We have some values over here, so let's simply have the values here as well. So template values.ml, we have the values.ml over here, and that's gonna be this one, and these values are actually being used over there, and that is it. So these are the things that we have gone through. Again, we have to know more about it. I know this is something that's gonna be done very soon. This Postgres chart, exactly how Helm works. Helm is used for creating the chart, how you create the chart, how you just simply put the values inside the template that you have created. We have now basic idea about it, and of course there's advanced, not advanced, but there are a few more things that we need to know. And then we will be creating many templates as well. So it's not like this is the end, this is just the beginning, but this is something will be done tomorrow probably, because there is something else that we have to do and we don't have a lot of time for that. So we have already created ls, eks, kget nodes, whatever we have to do we have done. Kget pods, if I try to get all the pods, that simply means we still have the post this Postgres DB pod that we created. So let me say Helm ls, I'm gonna be getting this particular thing. Let me uninstall this. So Helm uninstall, and we'll be just simply removing everything whatever got created using Helm. It will be removing everything. So kget pods for all, and right now I'm not gonna be getting anything from Postgres team, and these are the default ones that are running. Okay, that's fine. ls, and let me do one more thing, that k config use not use get contexts. These are the two contexts that I have. First one is the kind local, second one is the Amazon EKS cluster that I have. So I'm gonna be switching the context over here. So k config use context, I'm gonna be using the Amazon's one. ls, the context has been switched, k get nodes, and right now I'm getting these nodes. Pretty simple, interesting. So we have the node created. Earlier we created the local cluster, and then we deleted that, and that hasn't even been deleted. We have just simply switched it, and then we created our EKS cluster. The configuration is here. I have even talked about it quite a number of times. Whatever we have added, there is a reason behind this. You can just simply know more about it by giving it to the chat GPT and all. Coming back to this one, there are a few steps that we have to go through. This is this thing. So first of all, we had to create a cluster. We have already created a cluster. What is the goal right now? The goal is this, that horizontal pod auto scaling. Pods should be auto scaled. If the traffic increases, the number of pods should be increasing automatically. And as the number of pods increasing, so pods are gonna be inside a node. So inside a node, there can be many pods running. And in case those pods don't fit inside that particular node, so new node should be created. So node auto scaling should actually happen. And we are gonna be just simply managing some resource and all. We are gonna be talking about request and limit and all. Having said that, we have already talked about. I've already talked about that enough. This is just gonna be the practical stuff. Maybe I will be explaining a few things on the go. So cluster has been created. Let's talk about the policy. When it comes to the policy, so you need to create a cluster policy on AWS in order to enable. Why do you need this cluster policy? So that you are actually able to perform these actions. Just a minute, something went into my. Okay, there was a bug type something. Never mind. So these are the policies that you want to create. So version is this, and statement action. What are the actions that you are actually allowed to do? So auto scaling, describe auto scaling groups, set desired capacity, terminate instance in auto scaling group, describe launch template version, describe node group. So you should be able to do all these things. For this thing specifically, you will have to create the policy. So you will have to how you create the policy, I will be talking about that, where you actually need to save it, and if it is gonna be allow resource is gonna be for everything, as simple as that. So let me copy this thing from here. You have to just simply copy it. So copied, you have to go to your AWS account, you have to go to your policy. So of course I have to search IAM over here, and once you search IAM over here, so over here you get an option for the policy. This policies you get over here. Simply click on create a new policy and click on JSON, paste everything over here, click on next, add the name over here, and the policy will be created. In my case, that is already created. Once the policy is created, what is the next thing that you have to do? Once the policy is created, if you search your policy by name, what was the name of our policy in our case? The name was cluster AutoScaler policy that we created. So if you search the name, you will be getting the policy over here. So cluster AutoScaler policy. This is the policy that got created, and the next thing is that once the policy is created, you will have to add that, of course. So policy is created. Even if you just say this thing right here, that all types customer managed policy, so you are going to be getting the policies that are created by you. So this is how it's going to be going on. So we have gone through this step as well. We have the policy in my case that is already created. The next thing is that you have to apply that policy. Let me talk about this command, exactly what it does. By the way, clear the terminal and let me go through this command step by step. So what I'm saying, EKS create IAM service account. So a service account will be created inside that cluster EKS. Ultimately, why do you need the service account? This service account will be using that this policy at the end of the day. So if you actually worried about what is the use of service account, so HPA, AutoScaler, RABC, IAM policy, EJS, don't really have it in here, but ultimately service account will be using your policy that you created, and that is why it needs to be configured. So EKS CTL create IAM service account will be created so that you are actually allowed to do all those things. EKS, this is gonna be the cluster, namespace cube system, name cluster AutoScaler, this is gonna be the cluster AutoScaler is the name of the cluster. Hopefully that's the one. We haven't even created the cluster, but we will have to make sure that This is the cluster, this is the name of the cluster. By the way, whenever we are creating the cluster, let me see that we have created the cluster, right? Not AutoScaler, whatever we need to create for that. RABC. So cluster AutoScaler. This should be the name of the RBAC. Why do we need it? We will be talking about this. And this RBAC is mainly used for auto-scaling the node, and for that you will have to configure it. But yeah, the name should be, this is the same name by the way. So you have EKS CTL create IAM service, you are creating that EKS cluster. This is the name of the cluster that we have. Cube system is the namespace. It should be added to the Kubernetes system with that particular namespace. Name cluster AutoScaler. This is gonna be the name of the AutoScaler. So the AutoScaler that I create for the cluster, for that it will be used ultimately. This is where we are creating service account, and this service account's name is cluster AutoScaler. What is the use of this service account? This is mainly used for enabling auto-scaling and all. And attach policy RNM AWS IAM account ID. We need to have account ID over here. Policy cluster AutoScaler. AutoScaler is the name of the policy that we created. This is the cluster AutoScaler policy that we created. The same policy is going to be used to override existing service accounts and approve. So if I have existing accounts, that's gonna be overridden, and then I am just simply gonna be approving everything. So this is the command that you have to just simply run. I'm gonna be running it. For that thing I need to have my account ID as well. For getting the account ID, you have to just simply run well, I need another terminal here. AWS get AWS CSTS get caller identity. So from here you are gonna be getting your account ID. Once you have your account ID, you have to just simply paste it over here. So coming back to this one, again there can be better ways as well. All the things that I'm discussing about here, I came to know using ChatGPT, configured everything, made it somehow work. Then I know, okay, if I do this, high possibility that this is gonna be working. By the way, that's what I'm gonna be checking right now. I hope that is the same. Caller identity, it ended with 0. Let's simply stop it. So caller identity has 0 here. Run it, and hopefully it's gonna be done. So what it is saying that was that metadata service account that existed in Kubernetes will be updated as override exist service account was set. No tasks, so it did not find any. Just a minute, let me copy it again. Let me paste it over here. This is the service account that I had. Copy it from here. Let me go to this one. Let me paste it over here. Let me run this. Metadata service, it is not able to override, probably because there are no AutoScalers right now. AutoScalers in the sense cluster is AutoScaler. I haven't created that yet, and because of that thing, it is not able to do that. If it gets compulsory, we will be applying it later at the end as well. So by the way, let's get rid of this. Clear the terminal. Well, this could not be added mainly because, if I'm not wrong, that it needs a cluster AutoScaler, and that hasn't been created yet. By the way, why do we need this RBAC and RBAC.ml that simply creates cluster AutoScaler service account? I think for adding this thing, we need to have this, if I'm not wrong, but we'll see exactly how it works and all. By the way, why do we need RBAC? Even I have this properly mentioned over here, that you need RBAC Kubernetes permissions allow AutoScaler to read a cluster state. So if you want your AutoScaler to be capable of reading the cluster state, exactly how much CPU uses and all is happening, so at that time you can use this whatever we are configuring using RBAC file, that just simply allows that. So yeah, in AWS there's a lot of configuration. Right now I'm just simply gonna be going with this. So again, this whole configuration, if you want, I can give you, but you can just simply get it written by the AI as well. So this is all that I have got. So what we are actually doing over here, a service account we want, metadata cluster AutoScaler, namespace cube system, and RBAC authorize. This is just simply gonna be authorizing. This cluster rule is gonna be this. Metadata name is gonna be cluster AutoScaler. There are some rules. These are the rules: API, resource, verbs, and then there are these rules only. Again, I haven't gone deeper into it. This is just for the learning purpose. Probably in future I will be digging deeper into them. These rules allow me to scale my auto scale my auto scale my cluster and nodes mainly. So that's enough for now, especially because as I have just started, there could be some things that can be extra and all, but okay, AI gave me this, I checked this worked. Now whether this is good for production or not, that doesn't matter. When I'm gonna be working on production stuff, at that time I will be going through each and everything exactly what they do. For now, these are the rules that enable my cluster to be able to just simply that enable my AutoScaler to be able to read the cluster metrics and all. And then RBAC authorize, this is the cluster role binding that I am creating. Again, these things are needed for making sure that cluster AutoScaler happens, node AutoScaler happens. RBAC authorize cluster role, and kind is gonna be service account. And the main problem, if I'm not wrong, by the way, well, that's bad. Yeah, here we are. So when we applied this could not get approved or applied because there were no tasks. So this needs to be done first, and then this one, if I'm not wrong. So let me copy it again, everything from here. Do not ask me what like how you got it. I took the help of AI a lot, literally a lot. Even made AI just write everything, checked it whether it works or not, and finally got this. And am I 100% sure it worked initially? This time let's see whether it actually works or not. If it works, that's it. If it doesn't work, who knows? Okay, then let me inside. Oops. Arey bhai, rbac.ml. Inside this I will have this rbac. Once I have this, I'm gonna be just simply applying it. ls cd, well, cd, oops, ls k apply f rbac ml. This is gonna be applied. Let's wait for a while and it will be done. What is the next thing that we have to do once it is applied? Well, this has been created. So ultimately, if you say k get rbac, I'm not sure you are gonna be getting anything. Yeah, you will not, but it has been applied. Okay, so this particular thing is done. What is the next thing that you have to do? The next thing is that you have to create AutoScaler. So cluster AutoScaler is something that needs to be created. So this, what was this? This was the service account that you created. What is the next thing that you have to create? You have to create AutoScaler, a deployment. This is the configuration. This is the main deployment that actually scales and downscales. Scales up or scales down the container depending on the need. So let me copy it. This is gonna be AutoScaler cluster.ml. So vi and AutoScaler.ml. I hope that's the name, AutoScaler.ml. And I'm gonna be pasting everything over here. Let me even talk about this, what it does and all. Coming back to this one, AutoScaler.ml, it is just simply saying that we have a deployment file. The name is cluster, this cube system, this is gonna be the namespace. Replica, I need only one replica of the AutoScaler that simply scales up or scales down depending on the load and all. And this is gonna be the labels that it is using for upscaling and downscaling. And at the end of the day, this is gonna be the cluster. It will be using this particular image, AutoScaling image. And a few things have been configured over here. What are they? Cluster AutoScaler, cloud provider, AWS, node group. This is really important. Node group auto discovery. It automatically discovers your node groups and also you don't really need to worry about this. And here you have to just simply pass the name of the file. So EKS cluster, sorry, name of your EKS cluster that has already been passed, so we don't really need to worry about it. And balance similar node groups, skip nodes with the system ports false, skip nodes with the local storage false. This is nothing but the configuration that you are creating. Okay, as simple as that. Let's apply this one as well. lsk apply f and AutoScaler.ml. This is gonna be creating the deployment. You can even get that. So k get deployments for all. Let me just simply get the deployment. So this is the new deployment that got created, AutoScaler and all. This is something that we created right now. It is even running. Great, we have gone through this step. What is the next thing? As we have gone through this, so now it's time to create a sample app. Whatever we did so far, we created a cluster, we created a policy, we created a RBAC and AutoScaler. These, first of all, cluster is of course inside that only you are gonna be running everything. Policy was mainly for allowing you to do some kinds of things inside the cluster. RBAC and these AutoScaler configuration was mainly for enabling your AutoScaler to auto scale the nodes or auto downscale the nodes and all, and then we will have a sample node, sample app, in the sense an app that will be running. That app will be getting the load on itself, and if the load gets a lot, it will be just simply auto scaling the pods and all. So we need to have a manifest.ml, as simple as that. This is the ML file that we have. Again, I will be talking about it, what it does. No need to worry about this. The file that we need to have, that's gonna be many, or this is gonna be actually a backend. So inside, oops, because we are gonna be creating a backend over here. So let me have the files over here. Manifest.ml. This is the deployment file that we have. What is this saying? First of all, I'm gonna be creating a namespace. The namespace is gonna be backend team, and then a few config maps over here, and I need port and I need big value. Ultimately, inside my app, a loop will be running till this particular thing, as simple as that. So this image I'm using over here, unstoppable the coder backend app latest and all. So what it does, inside this particular image there is a express app that simply runs a loop till this particular value, as simple as that. And 1 2 3 4 5 6 7 8 9, I hope it's gonna be working. And then we have the deployment over here. So deployment got created, backend team is the name, 2 replicas are gonna be running, and selector match labels, simple, these are the labels that are used. Important thing is over here. So this is gonna be the image that will be used. I will even be talking about this image, or I can say Docker images. I should have that image over here. That's the backend app. What is the name of the image over here? Backend app. Yeah, this is the image. Let me show exactly what's happening inside this. Come on, crazy. Here we are. So the image that we have, this one. So Docker run port number 3000 by 3000. This is the image that I want to run. Let me run this. It is running right now, and as it is running, Docker process status, hopefully that is not running right now, or that is running, that is still running. That's a good thing. By the way, I'm gonna be executing inside that. So Docker execute in the interactive mode inside this particular machine. I have to go. Come on, terminal. Inside this particular machine. Yeah. So first of all, copy it. Then why am I facing the network issue? Never mind, even if I'm facing. So this is normal express application that gets the values, big value from the process env, and port number as well. Once it gets the port number, it just simply locks the values, and after that it has just a normal route, home route slash route, and it just simply says that it just simply runs a for loop till that big value, and then simply returns the response with the port number and the value, and then listens on this particular port. Whatever, this is just simply, whenever it gets the request, it just simply runs a big loop, and then it returns the response, exit. So that's what this image does. We already have this image, so we are not going to be creating this. I created it in the morning. And container port number, so on this particular port it will be running. Resource request. A resource request is that minimum 500 millicores I need. So my port, when it comes to my port, there are 2 core ports. So I will have 2 core ports, ports, nodes actually. And if I want to start a node, minimum that should be taking 500 millicores. Okay, if there is not 500 millicores in space, that will not be starting, as simple as that. Maximum it can actually take up to 800. So it can actually go to 800. Let me make it 700 or something, so that it doesn't take a lot. But yeah, this is the limit. This is the request, that it is gonna be minimum taking 500. If you want to create a pod, there should be 500 millicore space, otherwise that pod will not be created. That will be in the pending state. Limits this much it can use max. And then and especially how this is calculated, like CPU, how this pod auto scaling happens, how the number of pods, how many pods we need and all, how it calculates and all gets calculated. We have already talked about it in detail. By the way, this is the resource limit. And when it comes to environment variable, I need a port that comes from backend config that we have here at the top. So from here, this is the config map that we have created, and from here the values are there, are assigned here. And similarly, I have big value over here. Done. Then creating a service. That service will make sure that this is the cluster IP service, runs on port 80, forwards the request to the port 3000 to that particular pod. Again, not gonna be talking about it. Have talked about it quite a lot in detail, even in the morning, even in previous lives and all. I hope you understand, and I'm just simply gonna be applying it right now. So let me ls cd k apply f backend manifest. So ultimately what will happen, a backend will be created. So if I say k get deployments for all, let me get all of them at once. So I'm gonna be getting one more deployment, that is the backend deployment. It will have two replica sets. Let's see whether they have created or not. Two of them are running right now, so that's great. What is the next thing that we want? We want to create a load generator. Load generator in the sense, okay, this is the app that is running, great, inside a pod. Now I want to send the request to that particular pod, maybe a lot, n number of times. In that case, I'm gonna be creating another deployment, this load manifest.ml. So I'm gonna be doing nothing but creating load manifest.ml. What will this do? It will create another pod that will be sending the request to this particular pod. So I already have two pods running over here. So okay, get pods that belong to backend team. Backend team. So these are the two pods that are running. As these pods are running, now I have to send the traffic to them, right? Then only the load will increase. So for sending the traffic, I'm gonna be creating another pod that will do nothing, that will just simply send the traffic to this. Okay, so let me create this. Inside this I don't have anything, so let me copy the whole configuration. I will be talking about it. So what am I doing here? Creating deployment. This is the name of the app. This is the backend team that it has that same namespace, backend team, so that it belongs to the same team, so that it can just simply send the requests and all. Coming back to this one, replicas, I am gonna be having only one replica that will be sending the request. I can have even two and they are gonna be sending requests and all, but we can just manage that. Match labels, this is gonna be the label for that. And lastly, we have this load generator. This is gonna be named busy box. What is busy box? This is just the image that simply runs. Busy box, it runs and then it stops. And if you just sleep it for a while, or if you run a while loop, it just simply keeps running and all. Alrighty. So I'm just simply saying that whenever this image runs, so at that time I'm inside the shell, this is the command that I'm gonna be using. What is the command? While true. This while loop will be running again and again. What will I be doing here? I will be using wget. I will be just simply sending a request to backend service. What is the backend service? This is the backend service that we created here. Backend service was created for forwarding the request to the deployment app that we have, right? So this is the backend that I have. The service is attached to this only. So backend team, this is the namespace, and app is backend. That means this is the selector. So wherever, whichever pod has this particular label, if I talk about this, so yeah, this particular deployment does have the label. So it will be forwarding the request to those labels and load balancing the stuff and all. I hope it does make sense. Coming back to this load manifest, it will be just simply sending the request to backend service again and again. As the backend service is already running on port 80, so I don't have to specify port 80 over here. It will just simply be sending the request and done. It will be done. That's it. Again, resource request, minimum it can take 100 M and maximum it can take 200. Let me make it even 300 by 500 or something. Depends on exactly how much you wanna just give it. But yeah, this is how it just simply goes. I hope it does make sense. I'm gonna be applying this as well. So k apply f and backend load. Let's simply apply this. And right now, if you try to have a look over here, k top pods that belongs to the backend team. So here you will be saying the uses. Right now 1 mm is being used. Soon see 1 m in the sense 1 millicore. Soon it's gonna be increasing. So let's wait for a while, because from the load balancer pod the request should be sent here. As the request is sent, it should be increasing. It should be getting the requests. Let's see, it is not increasing yet. Alright, it is started. So I got a load generator deployment. So this is the load generated pod got created. This pod is sending the request to these backend deployment app pods. So these are the backend pods that are running. This is the load generator pod that is running. This load generated pod is simply sending the request to these. And if I just simply see, so you can just simply have a look over here. The load is increasing 400 M, 358. But again, scaling will not happen. Only load is increasing. The pod number of pods always remain the same. Now the question comes, how you will be increasing the number of what? The number of pods first of all, then I will be increasing the number of nodes as well. So for increasing the number of pods, we have already gone through these many things. Load manifest, we are running this stuff over here. Load is also increasing. Metric server, I don't really think I need this. because without this it works directly. HPA, it simply means horizontal pod scaling. Now as the load increases on the pod, so how will you be increasing the number of pods? For that thing we have to run this. I'm gonna be explaining exactly what it does, but let me create first of all. So inside oops, I'm gonna be creating one more file, that's gonna be hpa.ml. paste everything over here. What am I saying? I'm just simply saying that this is the horizontal AutoScaler pod metadata backend HPA. It will be increasing the pods of the backend. This is the team namespace. On the basis of this team only, it will be finding the pods and all. And scale, what will it be scaling? API version this. Kind is the deployment, and what is the name of the deployment? Backend deployment that we have already created. So if you actually have a look at the backend deployment over here, this is the deployment that we created. This is the one. And this deployment, it will be just simply increasing the pods and decreasing the pods here. Alrighty, coming back to this HPA ML, minimum replicas to minimum I want 2 replicas of what? 2 replicas of the pods. So 2 pods are gonna be there. 2 replicas can be there. Maximum can be 10. Matrix resource on the basis of what? It will be just simply increasing the number of replicas or decreasing on the basis of the resource. And what is the name? Resource CPU. What is the target? Target is gonna be the utilization. If the average utilization goes over 50. So if CPU utilization goes over 50% at that time, it will be increasing the number of pods. Over 50% on basis of what? On basis of resource request. What is the resource request? By default, I have given it 500 M. So there are gonna be many pods, and those pods are gonna be using some HPA utilization. HPA utilization in the sense not real CPU utilization, rather the utilization of that particular pod related to resource request. Yeah, something like that. I have even talked about this enough, so I'm gonna be not talking about right now. But at the end of the day, what I'm saying, that when it comes to this manifest when I created, I just simply said over here that when it comes to this resource request, so it needs minimum 500 M. So whenever the request comes to this particular pod or any pod that has this configuration resource request, so the minimum resource request is 500 M. That simply means you should have at least 500 millicores space in your node to create this pod. And once this pod is created, so minimum I mean, of course, it has already the minimum millicores. That simply means it can use this much easily. Even it can go up to 700 M, 700 millicores. So that simply means this much storage it already has. It can even use extra. And what is the limit? That limit is 700. So it can use its 100%, not only 100%. It can go beyond 100% as well. Alrighty. And what is the condition that we have? If the CPU utilization goes 50 or more than 50%. So first of all, you will calculate the CPU utilization of all the pods. So if you have 2 pods running, so you will be calculating the CPU utilization of the pod number 1, not CPU utilization, pod utilization, I must say. So utilization of the pod compared to this CPU request that I have given. So compared to this much space, you will be calculating how much it's being used. If it is using 500 all space, that simply means 100%, not 100% of the CPU, because CPU has 2 cores, ultimately 2000 millicores, right? So compared to this referencing, keeping this particular space in mind, you will be calculating the utilization based on this particular resource request. So when you calculate the utilization based on this particular resource request, so you will be calculating the uses based on this resource request for all the pods. Once you get the uses on all the pods, then you will be getting the average. Once you get the average, then you will be checking, okay, you got the average utilization, ultimately current utilization. Once you got the current utilization on all the pods, so if you have 10 pods or suppose 3 pods, so what is the average utilization among them? If that is over 50%, at that time you are going to be increasing. If that is not, then okay, you don't really need to worry about it. So this is how it just simply goes, and that's what I get over here. What I get here, if once I apply this, then I'm going to be getting. So let me apply this as well. So HPA ML, if it goes over 50%, again this is automatically calculated. So even if you don't understand, that's fine. Your HPA ultimately Kubernetes will be doing this job for you, but you should know how the things are actually being calculated. So let me just simply apply it as well. So k apply f hpa.ml. Once you applied this, so you will be getting get HPA. By default you will not be getting any, so you will have to mention the namespace over here. What is the namespace for this? The namespace is the backend team. So let me add this backend team over here. Backend team over here. Once you added this, so now it is giving you the CPU utilization. Earlier I talked about how it calculates that. Again, as it is already calculating it, so you do not need to worry about it. It is just simply saying that CPU, what was the target value? Target value was 50%. If the CPU utilization on all the pods, I have 2 pods right now, 2 replicas. So on 2 replicas, the CPU utilization is 62%. This is the average, not on one pod or second pod. It is the average. And as it is already more than 62%, so it will be increasing the number of pods. Let's see whether it increases or not. Earlier the number of replicas were 2, now it increased to 3, and the CPU utilization is still 55%. It will be increasing even more. So let's see. It is still 53. It is more than 53. So there should be one more replica. Wait for a while. One more replica should be created. Initially it had 2, and then slowly it created 3. It is still 53% or something. So soon one more replica is going to be created. No, it's not gonna be created because it has come back to 43%. So as it is 43%, less than 50, that simply means new replicas are not going to be created. Now what do I need to do? I need to send more traffic so that it increases number of replicas. So let's try to do that. 49%. Yeah, it's not increasing that. 50% still, I'm not sure whether it will increase. If it goes below 50, then of course it will not be increasing that. Uh, 44%. Yeah, it will not increase by default. I will have to increase the load. So k get pods n backend team. This is the load generator that I have. Let me go inside the load generator and send more requests to that. So what will I be doing here? K execute inside the node generator. I need to go to this particular load generator, and from the load generator side I am gonna be sending more requests. So I need to mention the name over here, backend team. Now I'm inside the terminal of the load generator. What I have to send from this terminal, I have to send more requests. So I'm gonna be just simply saying I want to run one more while loop. That's gonna be true. And what do I have to do? Using wget or something. Wget, what was the command here? I forgotten. The same command that I used there. Come on. Load manifest. This was the command that I was using. I'm gonna be using the same command here as well. Copy it and paste the same command over here. So this is the command. This command will just simply run a while loop using wget. How it's sending in all, I got it from the chat GPT again. Using wget you can just simply send the request. I think curl can also be used over here, but never mind. Let me try to use curl. Well, will it work? Let me try to use curl here. Curl is also used for sending the request and all. So if I use curl here and send the request to this, let's see. Curl not found. Okay, curl is not installed. That is why it was using wget over here. Understood. If the curl was installed, then of course it would be using that. Wget is there by default. I will be learning more about exactly how wget works, but for now let's simply send the request. What will happen? It is sending even more requests to there, and it is getting the result. That's good. The requests are being sent over there, and as the requests are being sent over there, now let me check the load. So k h get HPA backend team. If you actually check out the load, that is 47%. 47 should soon the load should be increasing. 47 is still 47. 81%. As 81%, new replicas are going to be created. Great. It's still 81%, but no replica. Wait for a while. New replica should be created. 75%. 5 replicas are here right now. 3 to directly 5. There was a lot of load. New 5 replicas and still load is 75%. So let's wait for a while. Now it is going to be stuck over here. Why? I will tell you the reason. Am I facing the network issue right now? It is saying that 5 replicas are here, but load is still 57%. The load hasn't come down. 51, that's okay. 6 replicas are here right now. Great. So 6 replicas are here and load is around 50%. Once the load gets less than 50%, it will not be worried about anything. Great. 49%. Load has come less than 50%. So ultimately it is fine. So 6 replicas are there. Great. If I k get pods and backend team, so far we haven't increased the number of nodes. But if you actually have a look over here, few replicas, few pods are still pending. Why? The simple reason is there is not enough space in the node. Okay, it tried to create more pods, and it tried to assign to those pods nodes, but there is not enough space in the node, and because of that thing, it is just in the pending state. So if I try to get this, the load is 48%, the replicas are 6, that's okay, it is able to manage it, but it actually tried to create one more, but it could not create that. The load is around 48%, that's a good thing. 47% or something. So what I'm gonna be doing? I'm gonna be sending even more load. So let me send even more load. How will I be doing that? Let me exit from here. Let me use another terminal directly, because if I use this one, yeah, that's better. Let me go to this terminal. From here I'm gonna be sending even more load. So ls k get pods that belong to the backend team. These are the pods that I have. What do I have to do? I have to go inside this load generator, and I have to send even more requests. So k execute interactive mode, and I have to go inside this terminal belongs to the backend team sh. Once I'm inside this, I'm gonna be copying the same command that is used for sending the request to, what was that? Load balance. This was the one. Copy it from here and come back here, paste it over here. It's gonna be sending even more requests. So the more requests are going there to the load generator. What will happen now? If I actually come back here and check the load here now. Right now load is 42%. That's good. But have a look. Keep having a look here. 42. It will suddenly increase because I'm sending even more requests. 42, 52%, slowly increasing. 52. Okay, wait for a while. Okay, wait. What else? You can't really do anything except waiting for it. 58%. It is slowly increasing as the more requests goes there. But this number of replica is not gonna be increasing. Why? Because there is not enough space for creating new replicas. So right now there's only one way. 7 replicas. It is saying that 7 replicas are created. 51% load. But is that really? Let me see. Still load is more than 51%. So let's wait for a while. 58%. It is saying 7 replicas have been created, but the load is still 58%. So shouldn't it be increasing the number of replicas? Shouldn't it be increasing the number of pods? But it cannot, because there's not enough space in the pod, ultimately node, and it is always gonna be more. Oh, number of replicas 9, but let's see, it has created 9 replicas. That simply means the request should come below 50%. The load should go below 50%. Is this actually gonna happen? 49%. That's great. Okay. Let's wait for a while. The load has actually come below 49% just because there's a. But 9 replicas, that doesn't make any sense. I don't think 9 replicas have been created. And let me see. It is showing 49% because the load is actually being balanced among many pods. That's a good thing. But it is saying that it has created 9 replicas, 50%. But is that really so? Let me see. K get pods and backend team Wow, that's such a good thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, it has created that. Great. Let me send even more. Okay, great. If it is able to create the load, that's okay. Not really big problem. 9 pods are there, right? Time to. Let me see. I think it should be getting more load, but okay, it is not getting that much load as much load as I want to just simply send. So k get a pods in backend team. Let me send even more load. So 9 replicas are here. There are gonna be even more. K execute in the interactive mode. This is the terminal that I want to go in, and sh we'll have to mention the team backend team namespace over here. Yes, let me copy paste the same command that was used for sending the load. This was the one. Not able to send as much load as I think this is gonna be the last time when I actually need to send the load. Voila. Copy. Done. Oh, new requests are being sent. That's great. Coming back to this one. How many pods it can actually create? And will it be able to handle the load? It is actually able to handle the load really easily. That simply means 10 to the power 9 is not really a good number. It should be more. That's insane. K get pods. Sorry, not pods. K get nodes. What the hell? I did not mention that new pods are actually getting created. That is what I was thinking, that why is it actually able to handle this much load? The thing is that new nodes got created. I did not configure this. I configured this. If I don't remember, I should remember that well. HPA, node AutoScaler, deployment cluster. This is the didn't I do this? RBCA AutoScaler. This is where I did the same thing, right? This cluster AutoScaler that I created, this was responsible for increasing the load. Seriously? Sorry. I thought I did not really apply it, but it was already applied over here. So I can just simply delete this thing from here. I thought it is not done yet, but it is already done. Inside this particular section, this is the AutoScaler that I already created. I did not keep this thing in mind, but I created that. So what is actually happening? RBAC. Clusters are actually being increased. Sorry, nodes are actually being increased. So there are 4 nodes right now. So K get nodes. Initially I had 2, but the number of nodes also increased. So this is why it is able to handle the load. I was just simply thinking I'm sending so many requests from so many terminals. Still it is able to handle the request. It is not able to handle. It is just simply created more nodes. Now there are more nodes, more pods. That is why they are able to handle the request. K get pods and backend team. So if you actually have a look over here, these many pods are running and they are actually handling this much request. K get HPA and backend team. So 52% is being used. 9 replicas are there. So ultimately there are 9 replicas. Those replicas are sort of able to handle the load. 52%. It should be creating one more if it remains 52%. But let's see whether one more replica gets created or it will come less than 50% or something. That's great. So ultimately we are running 9 replicas. That simply means 9 pods are running. And for running those 9 pods, 2 nodes were not enough. By default I had 2 nodes with 2 cores each. But they were not enough. That is why 2 get nodes. 2 more nodes got created. So over here these 2 more nodes got created. And this is how it went. K get deployment backend team. If I describe it, so K describe deployment. This is the name of the deployment. Backend team. If you actually have a look over here, so initially there were 0 to 2, then 0 to 3, 3 to 5, 5 to 6. These are the replicas. Okay, so these are the number of replicas that I have. Great. So ultimately, this is how the number of the replica increased as per the load, and as the number of replica increased, the number of okay, get nodes. The number of nodes actually increased. So if I actually have a look over here, so k get k describe. Can I describe a node? I can, and it is just simply saying that this much is being used. Okay, that's fine. I can even know more about the node as well. But this is how things actually work. Let me stop this now. Enough. So k get HPA and backend team. We are able to scale the pods. We are able to scale. Okay, I mean, as now slowly the load is gonna be decreasing, because now the load is around 48% or something. Even 10 replica were there suddenly, because the load was around 56% or something. As I have stopped a few processes, let me stop these as well. Let me stop this, exit from here. So what will happen? The load will slowly decrease. As the load slowly decreases, the number of replicas will be decreased as well, and even nodes are gonna be decreased, and that's what we want to see. ls backend team. Right now the load is only 31%, so slowly the load is coming back. 10 replicas are there. What should happen? These replicas should slowly decrease. So that's what we want to see, whether this actually happens or not. 31% load, 19% loads, because 10 replicas are there. They are easily able to handle the load that is going. So slowly should be decreasing. 19% roll, 14%, even it is even gonna be lesser and lesser, because 10 pods are there, man. Even if it comes to k get nodes, so still 4 nodes are running. That's great, and that is why 10 pods are able to run. And 15%. Now I have to wait for some time, and after that the number of replicas are gonna be decreasing. So that's what I wanna check, whether the number of replicas decreases or not. And this is sure that if it doesn't have a lot of load, so the number of replicas are slowly gonna be decreasing, and this is how it's gonna be happening. And as for right now, it is gonna be taking some time, probably around 5 minutes or something, to decrease the number of replicas. It increases really quickly, but because it gets load suddenly, slowly it will be decreasing the number of replicas, number of nodes, even k get nodes. Right now the number of nodes is actually 4. Slowly it will be 3, then it will be 2, and it will remain at 2. So this is how things are gonna be going on. Alrighty then, that was it. As for this one, I know it will be done, so I will keep it on and see whether it actually happens or not. If it doesn't happen, then I will be figuring it out and letting you know more about it. As for right now, I know that it's gonna work in all. So let's see how long it actually takes to just simply decrease the number of replicas. So that was it. This was the thing. These are the steps that I actually have here, and even I have these things. Again, I got everything from the ChatGPT. I actually had to dig deeper into it quite a lot. I didn't know anything, honestly, like how it works and all. Because of the AI, it got possible to just simply learn this thing as well. Know more about this stuff, and what else could be better than this? The whole process, the flow was created by this. Do take the help of AI when it comes to learning. It's gonna change the way you learn dramatically, and it will help you a lot. By the way, that was it today. Resource management, HPA, even node AutoScaling, we have gone through everything. The Kubernetes section, that is almost at the end now. We are gonna be soon, within a week, a couple of weeks, 2 weeks. I need more to just simply sort everything out, and then we will have nothing but projects. So we are gonna be building many projects. We are gonna be learning about new fields and all. So it's gonna be fantastic. Alrighty, take care, and I'm gonna be catching up soon. Bye bye.